And so one of the best sources for understanding the C language and how they're writing it here in these Atmel demos was this PDF AVR 1000 getting started writing C code for the X Mega. This is an excellent, the best document I've found so far. It's not very big, it's not very long, it doesn't go into a ton of detail, but it does a really good explanation of how they set up their registers, use the bit mask, the header files, how their structures are arranged, how they use pointers, point to structures, enumerations, and stuff like that. So this is a definite read for even trying to start and understand what's going on in these programs. And here we're in the main C program for this demo, and you see basically it starts out initializing clock, the microcontroller, initializing the board, initializing the drivers for the display and for the SD card, and initializing the USB. And then you get into here like the main introduction, and you can highlight this line and right click it, and then you can go to implementation, and that's how you can start digging down deeper into what's going on behind the scenes, as it were. So you can see here for this main introduction, it's function, it's static, so that means that it's the scope is limited for this function to just work inside this main file, so it won't work in other files. And you can see here that the LED, power LED, gets turned on. And then this part here, it's asking in the main introduction, it's asking has the user clicked on I think it's switch 0 or switch 1. That skips the introduction and goes into displaying the sensor, the live displays, and that. And then each one of these functions you can highlight it, and like in this case, this function is going to draw a string of characters as part of the intro demo. You can right click it and go to its implementation, and you can see here where it gets, it starts getting fairly complicated when you're an amateur and you're just starting out. You know how basic functions are working, but here they're always using words, like assert, and getting kind of complicated. I'll try to go into this line by line, trying to figure out exactly what's going on to this program. But basically, we've got the demo set up here, so we're gonna actually program it into the board and run it. So first thing we'll do is build the solution. And this is a pretty big program, so it takes a while even just to build it. You can see the complexity. And we'll get some errors, well, not errors, but we have no errors. We'll get some warnings here. But next step is to program it into the board itself in the microcontroller. Alright, so we build a solution. Then when you want to program it into the board itself, go up to Tools and Device Programming. And you'll see a list here of if you get your programmer plugged in, it should give a list here You can see here the Mark II shows up, and the type of interface, PDI here, and then you click apply, and just to check to make sure that you got communications between your programmer and the board, you can almost always click on read here. So yeah, see, we have a good connection here. We got a device signature and our target voltage is showing up. If you had problems with your, it's not recognizing the programmer that, then this won't show up. It'll come up red, or it's not, it's not getting a proper target voltage, and you just have to reset or whatever. So program looks good, and then go into memories, and then before you hit program button, make sure that you're in the right file. Okay, it looks like, because if you're working on like another project and then you switch to this one, a lot of times it just seems to stay in the old file, and you'll have to update and make sure you get to the proper hex file for the program that you're trying to program into the board. Alright, so we got our hex file here. That looks good. And then you just click on the program. And it loads it in. Verify everything looks like it's okay. Went in. Then you basically I just filmed what my board did after I programmed it. And you can see it comes up with the Atmel icon. Switch, press switch 1 to skip the intro. Then it gives a quick explanation of what the demo's doing. And one switch turns on and off the USB, one ejects the micro SD card. And then you got your basic display showing like it's a sampling rate and temperature. And basically that's that demo program. And so you can see in the program that it's basically looking to see if the user had pressed on that switch to skip the intro, and if not, then it'll start displaying, like this function right here is going to display the Atmel icon. So we'll dig a little deeper with this function. We can see here we got the bitmap Atmel. This is the address that the pointer of the function is going to be pointing to, and basically this is the structure that holds tells what the width and the height of the Atmel icon that you see right at the beginning of the video, the beginning of the intro, where it displays Atmel. So this structure is storing the height, the width, and then it's storing in program memory. It's storing the bitmap, which you can see up here. Picture Atmel array, the bitmap basically is the picture of Atmel in hex form, and then the generic put GFX model generic put bitmap. This function is the one that outputs that bitmap to the display So, and, you can get down to the details of it here. Um, and there's a short explanation on the comment, where the function will output the bitmap from flash or RAM. The bitmap Y coordinate will be aligned with the display pages, rounded down. So if you place a bitmap at X coordinate equals 10 and Y coordinate equals 5, it'll put the bitmap at 10 and Y at equal to 0 because it's rounding down. Or if it's at 10, X coordinate is 10, Y's coordinate is 10, then it'll put the bitmap at X equals 10, Y equals 8, rounding down. I'll get into more detail of exactly what's going on in this function. Just a general idea that on the main, if a person doesn't press that switch, then it'll start. The first thing it starts displaying that Atmel icon, and going into the structure, and like I said, looking for the bitmap, the pointer pointing to the address where the bitmap's stored, and then outputting that bitmap to the display. Another example would be like, here where the power LED is the first thing that happens when you fire it up, it comes on, and that's what this function does, is turn it on. So you right click, go to the implementation of that. You can see here a define statement for LED 3, general purpose input output, and it uses the IO port create pin function, and assigns that LED to port D, pin 5. So if you go to the schematic of the board, here you see port D, pin 5, and then you can follow it down, and you can see it goes to the power LED. That's just a general overview. Like I said, I'll get into a lot more detail about what's going on.